Hello friends, I hope you all are doing great. Welcome to our YouTube channel The Engineering Projects. In today's tutorial, we will have a detailed overview of Arduino Pro Mini. We will first discuss the related theory, and later we'll simulate it in Proteus software. So, let's get started. I have divided this tutorial into 4 parts. In the first part, we will discuss the basic introduction of Arduino Pro Mini. Like what is Arduino Pro Mini, why we need to use it, why is it so famous, etc. In the second part, we will discuss its hardware architecture, where we will have a look at its pinout, and the different functions associated with these pins like communication protocols, PWM, etc. In the third part, I will show you how to add its library to Proteus software for designing its simulation. And finally, in the last section, we will design a small simulation in Proteus software. In the last video, Introduction to Arduino Mega 2560, I have interfaced the Mega board with LCD and keypad. So today, I am going to take it further, and will add a DC motor. I will control this DC motor with the keypad buttons, and will display the status on the LCD. I have also shared a complete tutorial on my blog, and its link is given in the description of this YouTube video. Now, first let's have a look at what is Arduino Pro Mini. Arduino Pro Mini is a compact, small-sized and application-type microcontroller board, designed by Arduino.cc. The size of Arduino Pro Mini is 1/6 of the size of Arduino Uno, so it's quite small as compared to Arduino Uno. We call it application type because there's no extra hardware components present in it. For example, it doesn't have a hardware programmer embedded in it, as in Arduino Uno, so we can't directly upload code in it. We need to use Arduino Uno or any USB to TTL converter in order to upload code in this board. Moreover, it lacks the USB port and DC power jack, so we need to use a 5 volts pin in order to power it up. It also lacks the ICSP header for connecting third-party modules. The microcontroller used in this Arduino board is at Mega 328 in SMD form. Arduino Pro Mini has 14 digital pins, starting from 0 to 13. These digital pins are used to interface digital sensors and modules with Arduino Pro Mini. Moreover, it has 6 analog pins starting from A0 to A5. These pins are used to interface analog sensors. We need to specify it in the programming, whether we want to use these pins as input or output. If we are interfacing any sensor, then we need to make these pins input, so that we could read the sensor's data, but if we want to control any module or motor, then we have to make these pins output, so that we could send instructions. These pins are also assigned with many other functions. For example, we also have 6 PWM pins in Arduino Pro Mini, which are used to generate PWM signals. In Arduino Pro Mini, pin numbers 3, 5, 6, 9, 10 and 11 are used to generate pulse-width modulated signals. If you want to control the speed of a DC motor, then you need to use any of these PWM pins. It also has 3 ground pins and 2 VCC pins. We need to provide 5 volts to this VCC pin in order to power it up. It also has 2 reset pins, which are used for resetting the board programmatically. Making this pin low will reset the board. There's also a reset button present on the Pro Mini board. Arduino Pro Mini comes with a crystal oscillator of 16 MHz. Arduino IDE is the official software used for designing and uploading code in Arduino Pro Mini, but unlike other Arduino boards, it doesn't have a USB port on it, so we can't directly upload code in it. As I told earlier, either we need to use Arduino Uno or USB to TTL converter in order to upload code in it. Moreover, it also has 2 LEDs embedded on it. The first one is power LED, it will turn on as the board will be powered up. Second LED is connected to pin number 13 and is used for testing purposes. When you buy a new Arduino Pro Mini, then first upload the blink code to check this LED. If it's blinking, your board's fine. If not, you need to buy a new one. Arduino Pro Mini supports 3 types of communication protocols, named Serial Protocol, SPI Protocol and I2C Protocol. These communication protocols are used for data transferring between Pro Mini and third-party modules. For example, GSM module SIM900 works on Serial Protocol, while RTC module DS1307 works on I2C Protocol, so we need to connect these modules with respective pins of Arduino Pro Mini. Arduino Pro Mini has 1 hardware serial port, which means we can connect 1 serial module with Arduino Pro Mini. If you want to connect more than 1, you need to use software serial library. Pins of the serial port are pin numbers 0 and 1, where pin number 0 is RX, used to receive data, while pin number 1 is TX, used to transmit serial data. Code is also uploaded through these serial pins, so the USB to TTL or Arduino Uno will be connected with these pins for uploading code. So, it's better to use software serial port for connecting third-party serial modules. Arduino Pro Mini also has one SPI port, which we can operate through these 4 pins, pin number 10, 11, 12 and 13, where pin number 10 is SS, short for slave select, pin number 11 is MOSI, short for master out slave in, pin number 12 is MISO, short for master in slave out, and pin number 13 is SCK, short for serial clock. So, using these 4 digital pins we can perform SPI protocol in Arduino Pro Mini. The third protocol is I2C protocol. Pins used for I2C protocol are A4 and A5. Here, A4 is SDA, short for data line, and A5 is SCL, short for clock line. Again, we have to define it in the programming, how we want to use these pins. Now, let's have a look at the built-in memories present in Arduino Pro Mini. Arduino Pro Mini comes with 3 types of built-in memories, named flash memory, also called ROM, SRAM memory, also called RAM, and EEPROM memory. Arduino Pro Mini has a flash memory of 32 kilobytes. It's a non-volatile memory, meaning the data in ROM memory will remain intact, even if we remove the power supply of the Arduino board. As it's a non-volatile memory, that's why it's used for storing the programming code or any permanent settings. Bootloader is a software code that is pre-installed in every Arduino board. It's installed in the flash memory of Arduino Pro Mini and takes around 0.5 kilobytes space, so from 32 kilobytes flash memory, 0.5 kilobytes memory is already occupied by the bootloader. Second one is SRAM memory. It's short for static random access memory, and usually called RAM memory. Arduino Pro Mini has a RAM memory of 2 kilobytes. It's a volatile memory, so if we reset or restart the mega board, RAM memory will get erased. This memory is used to store temporary data like variables. Third type is EEPROM memory. Arduino Pro Mini has an EEPROM memory of 1 kilobyte. It's a semi-volatile memory and thus can be erased by programming but remains intact if power is lost. So far, we have studied theoretical knowledge about Arduino Pro Mini. Now let's practically work on this powerful board. I am not going to work on a real Arduino Pro Mini board, instead I am going to design its simulation in Proteus software. If you want to learn the Arduino programming language, then I would recommend you to design simulations in Proteus. Working on real hardware is quite difficult, as you have to purchase the components and it also involves electronics. In Proteus simulation, you just have to design your circuit once, and then you can completely focus on your programming side. When I work on Arduino projects, I normally design my programming algorithms in Proteus, as testing with real hardware is too time-consuming. Proteus doesn't have Arduino boards in its components library, but we have designed its library, which you need to install in your Proteus software, and you will be able to simulate Arduino boards in it. We have designed 2 libraries of Proteus containing Arduino Pro Mini board. I have given both of these links in the description of this YouTube video. This library is titled as Arduino Pro Mini Library for Proteus version 2.0. If you install this library, it will only add Arduino Pro Mini board in your Proteus software. In order to download it, click on this download button and it will open this download page, where we need to wait for 20 seconds. And here's the link generated. Let's click on this button to download zip file, and here we got our zip file for Arduino Pro Mini Proteus library. I am going to click on cancel, as we will install this second library. This library is titled Arduino Library for Proteus version 2.0, and by installing this library you will get these 6 basic Arduino boards. So, let's install this second one, and again we need to click on the download button. Here's the download page and again we need to wait for 20 seconds. Let's click on this button to download the zip file of Proteus library. Here, we got our zip file. Click OK to open this file. And here we have this folder named Arduino Library for Proteus v2.0. Open this folder, and we have this folder Proteus Library Files, which contains the library files. First, we need to add these 2 files in the library folder of our Proteus software. So extract these files and now click on C drive. Program files. Here we have Lab Center Electronics, and then Proteus 7 Professional. Click on Library folder and now click OK. As I already have these files in my library folder, so I am going to click on Yes to all. That's it. We have successfully placed these two files in the library folder of our Proteus software. Now let's open our Proteus software. And in the Components section make a search for Arduino Pro Mini. Here select Arduino Pro Mini V2.0 and click OK. Let's place Arduino Pro Mini in the workspace. So, now we are ready to design its simulation. In the previous tutorial, I have interfaced keypad and LCD with Arduino Mega 2560, and today, I will first interface both of them with Arduino Pro Mini, and then we'll add a DC motor. I will control the rotation of DC motor from keypad buttons, and will display the status on LCD. So, let's search for a few more components. First I am going to search for LCD library, and here we need to select LCD 20x4. Next, make a search for keypad. I am going to select this small calculator keypad. It's a 4x4 keypad, means it has 4 rows and 4 columns. And we also need to search for pot-HG, it's a variable resistor. Select it too. Now, let's click the OK button to close this dialog box. Let's first place LCD in the workspace. Next we need to connect terminals, so clicking on Terminals mode, and here we need to select Default. I am going to quickly place these terminals, as we have already discussed this circuit in the previous video. Let's add their labels. Let's connect this variable resistor with the LCD, it controls the brightness of LCD. We need to connect a ground with the read-write pin, as we are writing on this LCD. Next, we need to connect these terminals with the Arduino board. Now let's open the Arduino IDE. And click on File, and then Examples, and here we have Liquid Crystal Library, and I am going to open Hello World example. Here we have the pins configuration. So let's assign labels to Arduino terminals. Let's compile the code to get our hex file. Here's our hex file, so I'm going to copy it. Arduino IDE creates this hex file in the temporary folder of the laptop. Now in the Proteus simulation, double-click on Arduino Pro Mini to open its Properties panel. And in the Program File section, paste the link of the hex file, and click OK. Now, let's run our simulation. LCD is not working properly. Let's stop the simulation. Here, I have made this mistake, we need to change the label of RS and enable. Now let's run it again. And yeah, it's working fine now. Let's stop the simulation to add the keypad. Here, I am going to place this 4x4 keypad. Again, we need to connect default terminals with its pins. We need to label these pins, and as I did for LCD, I am going to use the name of the keypad pins. We also need to connect these terminals with the Arduino board. As we are left with few pins, so I'm going to connect it with analog pins. Let's assign them the same labels as that of the keypad. Now, let's open the keypad example. So, File, Examples, Keypad, and click on Hello Keypad. This example prints pressed keypad characters on the serial monitor. Let's copy code from it and add it to our LCD code. First, let's remove these comments to clean our code. Now, I'm going to copy the library and paste it here. Now, let's copy this keypad initialization code and paste it here. We need to make few changes in the code, to make it compatible with our circuit. Here's the code which will detect the pressed key of the keypad, and will print it on the serial monitor. Let's copy this code. We need to remove this hello world message. And in the loop section, let's paste this keypad code. We are using 20x4 LCD. As we want to print the keys on LCD, so let's change this code. It's lcd.print. Now, we need to compile the code. And let's run the simulation. And we got this compiling error. As we are using a 4x4 keypad, so we need to change the value of columns from 3 to 4. Next, we need to change the characters of this array, and make it look like our keypad in Proteus. We also need to add the fourth column in each row. Now let's compile the code again, and we are not getting any errors. Let's run the Proteus simulation. It's working fine. And you can see, as I am pressing the keypad button, its characters are getting printed on the LCD. But it's not printing the correct characters. So we simply need to reverse the row pins. Let's compile it again. And run the simulation. And the keypad is working fine. As I told earlier, we are going to control the direction of a DC motor, and in order to do so, we need to use any DC motor driver, like ULN 2003 or L298. We have designed an L298 motor driver library for Proteus, which I'm going to download now. So, let's open this page, L298 motor driver library for Proteus. I have given its link in the description of this YouTube video. Click on this download button, which will open up the download page, and again, we need to wait for 20 seconds for the download link to generate. Click on this download button to get our hex file. Open this zip file, and then this folder, and here we have these two library files, which we need to place in the library folder of our Proteus software. Now in the Proteus components section, I am searching for L298 and here we got two results. Let's select this L298 motor driver. We also need to make a search for DC motor. And select this active model. Let's place it in the Proteus workspace. Let's lower it down to make some space. We need to connect the DC motor with out 1 and out 2 pins of L298. Need to make these 2 pins ground. Here, as the pins say, we need to connect 12 volts, 5 volts and ground. Finally, need to attach default terminals with input pins to get commands from Arduino Pro Mini. Let's assign them labels. And now adding same terminals with Arduino board itself. So, our motor is connected with pin number 5 and 6 of Arduino Pro Mini. Let's write the Arduino code for DC motor. So, first of all, I am assigning the pins of DC motor. Next, we need to make these pins output, as we are sending signals from Arduino. Now, in this key loop, we have to place an if check. If the pressed key is 1, then motor 1 pin will be high. While the motor 2 pin will be low. Let's compile the code to check the output. I forgot to assign labels to these pins. So, I am giving them the same labels as that of the input pins of the L298 motor driver. Let's run the simulation, and we got this error. It's a silly mistake. We need to place plus sign with the power signal. Let's run it one more time. And yeah, now there's no error. Let's click button 1 of the keypad, and as you can see here, the DC motor is now rotating in the clockwise direction. Let's add some LCD code to make it look presentable. I am quickly making these changes. Now let's run the simulation. And you can see, as I have pressed the key 1, the motor started rotating, and its status got printed on the LCD. Let's detect the second key, and here I am reversing the polarity, so motor 1 got low and motor 2 got high. Let's test it again. Now, you can see, when I press the key 2, the motor starts rotating in counterclockwise direction. But the LCD is not showing the data properly, and we got these 3 characters in the last line. So, let's quickly make some changes to the code. Need to test it again. And yeah, now we are getting good results. Let's copy it one more time, and now I am going to stop the motor, so making both of these pins low. Let's test it. As you can see, all these 3 buttons are working fine now. But there's a little bug present in the LCD screen, so let's quickly fix it. I have simply added the spaces, so that the screen got clear. It's not the best way, but it works. Let's compile the code again. We need to run the simulation. And now you can see, everything's looking fine. So, that was all for today. I hope you have enjoyed today's tutorial. I have given all the mentioned links in the description of this YouTube video. If you have any questions, please ask in the comments. Take care. Bye.